I think the noise function is really interesting, and we've seen that already in the last 2 episodes, and let's continue making some more examples. Let's start by looking in the reference. I'm gonna type Ctrl F here and look for noise. And we have used it sending just one value, one parameter, but we can see here in the documentation there's 3 options actually. We can send one value, we can send 2 values, or even 3. They are X, Y, and Z. And here it says for all of them that it's a coordinate in noise space. This space is not referring to outer space, but just a space like our screen. Our screen is a space. I want you to imagine something. It's gonna be a piece of paper, and you are here holding this piece of paper. And the piece of paper has a little hole in the middle. And we have here a landscape, maybe mountains and clouds and some trees. And you are looking through this little hole. And you see just one spot. Maybe you're seeing this part of the sky or a cloud or something, just through this hole. And you can move this paper to the left or to the right. This paper here is our noise function. And all these things that surround us is what here is referring to noise space. So we are here in a certain location. There is some space around us, and we can look through this hole and we can move it to the left and to the right. So we are using now only X. And whatever we see, this spot is the thing that noise is giving us back. Noise is giving us back a number between 0 and 1. Well, we can imagine here we would get a color, for example. It can be blue from the sky, or it can be different shades of gray or white from the clouds, or green. So we just, by moving this paper, we get something back. We get a color. Now we can call also noise with 2 parameters, X and Y. So the Y would be the vertical motion, so we can aim up and down. So now we have here our noise function, noise, and we have X and Y. So we can move around this paper and get different colors. If we change one of the numbers, we get some vertical motion in this example, and if we change the other number, we get some horizontal motion. And if you remember, we mentioned that we should change this value in small increments. Why is that? Well, the noise function has the advantage over the random function that with noise we can get values back which change slowly compared to the previous one. So if we are looking at points, for imagining this cloud, they will not change so much. Sometimes it will be a bit darker, sometimes it will be a bit brighter. If we change this value in huge increments, suddenly we are looking to the tree, or actually maybe we're looking to a car, which is red, and previously we had this blue sky here. So when we do this big increment on our variable, we may get totally different values, which can be okay, it depends on what you're looking for. Just to mention the Z parameter here, that would mean if you are moving forward and backward. So imagine you give 100 steps forward, then the environment around you would change, and the values you would get by looking through this hole would be different. And if you move backward, the same. The surrounding changes and the colors you see through the hole are also different. So that would be the Z parameter here. But for now, just let's start by playing with 2. So I'm gonna start creating, well, we don't need an animation actually. Let's draw some points from the left border of the screen to the right border of the screen. So I will start with a variable which is X on the left border of the screen, which is 0. and I will increment this while x is less than the width, then do something. And at least we would know we want to increment this variable so we don't stay inside this loop forever. I'm gonna increase the size of the screen a little bit, and I'm gonna draw a point on the screen at x. This is the horizontal position, and I will just draw it on the middle of the screen so we can see it's working. We have a straight line here. That's fine. So now let's apply here some noise. I'm gonna multiply actually the height of the screen by the noise function. And the noise will depend on x. We know we have to change this value. If we type just one fixed value, then we just get one straight line. So we want to change this value over time, or each time we call noise, we want here a different value, so we get a different value back. Okay, so now this looks very similar to random. And this is because we are changing our x variable too fast. And too fast, if you read in the documentation here, they recommend steps of 0,005 to 0,03. How can we fix this? Because we know we want our x to go from 0 to 400. What we can do is divide this number by 100, for example. So if before we were moving from 0 to 400, now this division here gives us a result that goes between 0 and 4. 400 divided by 100 is 4. We are calling noise, and the parameter we send goes between 0 and 4. What do we get now? Oh, this looks like some mountains now. Every time we run the program, we get some different shape. But we are still using just one parameter here, not two, like in previous episodes. So what other parameter could we add here? Well, we could add time. We can create a variable that is changing over time. And so this is with the purpose of animating our thing here. So I'm gonna add the typical things we need for animation, a setup to configure the basic things, and then I will add here a draw function, which will, I'm gonna press Ctrl T to format this. Okay, so now, well, if I leave this fixed for now, the second parameter, I'm just continuously drawing the same thing. To make it change, we need to change the second parameter, and I will call it time. So I will add here float time equals 0, and I will increase this. Time is time plus 0,02. And I'm gonna run this, and it makes this beautiful landscape thing. But it's all turning black because I'm not erasing the screen yet. So I'm gonna call background, and for example, white, or white background. So now we have these moving lines. They move up and down. It could be like water, but if it was water, it would be much flatter, don't you think? So how could we reduce the height of this water? Right now we are multiplying the height of the screen, which is 400 times noise, which is returning something between 0 and 1. So our vertical position for this point is anywhere between 0 and 400. If I want it to be a smaller number, then I can just multiply 50 instead. So now I will get a number. This product here is a number between 50 or 0 and 50. So now this looks more like water, like the ocean. But I want this line to be on the middle of the screen. So I can add a number here. This is usually called an offset. This part is fixed. I'm always gonna have 200 plus something. And this something is a number between 0 and 50. So the result is a number between 200 and 250. And there is our ocean moving. And it would be nice if all this lower part was colored instead of just being a line. How could I do this? Well, I'm gonna show it here. If this is our screen, and I'm just setting a lot of points here, instead of points, I could draw a line each time from wherever this point was to the bottom of the screen. And you can see the X is in both cases the same. That's the distance from the left border. So I'm gonna make here a line which goes from X and this long thing, which is some vertical position, to X and the bottom of the screen. Height is the bottom of the screen in this case. So now there we have something that looks a bit like the ocean moving. I let you change the color of the background and the color of the water, and you could even add a sun here moving slowly across this screen. That would be nice. So the important thing here to see is that we are calling noise, and noise, like in previous episodes, gives us a number between 0 and 1, but we are using actually 2 parameters. Each time draw is called, so for each frame of the animation, time is not changing. So I'm gonna draw one frame. Drawing one frame means drawing 400 vertical lines, so all these lines. And during this drawing of 400 lines, time is not changing. Time only changes at the end of my frame. Then I increase time. The next time draw is called, time will be a little bit different. That's why you can see here in each frame of the animation it draws 400 lines. It's really fast. You cannot see that. And then by sending a different parameter here, that changed a little bit. It just changed by 0.02. Then the shape it draws is a little bit different. Another interesting thing is here, if we are not using Y, it's really not important what you send here. It doesn't have to be any X, Y, or Z, but it's just 3 numbers that change slowly, or 2 numbers that change slowly. Even in our previous episodes, we use here something that was like time. It was a variable that was increasing over time to draw a line somewhere on the screen, but we were not using X.